Okay, so now let's proceed to construct some confidence intervals. Okay, so we're going to focus initially on two cases. These are not the only cases that you'll ever encounter, but they are by far the most important cases. And sort of having these under your belt is important. Okay, so case one, we're sampling from a normal distribution with a known variance, and we want a confidence interval for the mean. Okay, so sampling from a normal distribution, and we know the variance. Case two, same situation, but we don't know the variance. Okay? Okay, so let's consider case one. So what we're going to do is we want to construct a confidence interval, and we're going to construct the confidence interval based on a good estimator we have for the unknown parameter, the mean. Okay? And that, of course, is x bar. Okay? Now we know, since we're sampling from a normal distribution, we know not only the mean and the variance of this thing, we also know its distribution, right? Does everyone remember that? So we're sampling from a normal distribution, so the sample mean will have mean, mu, variance, sigma squared over n, and be normal itself. Okay? So what do we know about this function here, x bar minus mu over sigma divided by root n? What do we know about that? Yeah, it's a standard normal distribution, right? Normal 0, 1 distribution, exactly right. Okay, so we never mind the fact that we don't know what mu is. That doesn't matter. We're just doing calculations, so we just use mu here. Okay, so we have something in the middle that has a standard normal distribution, and what we want to do is we want to construct an interval. And remember, what is the definition of a confidence interval? We're looking for functions a and b such that the probability that a of x is less than or equal to mu is less than or equal to b of x is 1 minus alpha. Okay? So let's start with this step first. We've got something whose distribution we know perfectly, up to mu, whose distribution we know. And then what are these things on the outside? Well, this on the left, this capital phi inverse of alpha over 2, that's simply this number right here. Okay? It's just the inverse CDF of the standard normal evaluated at alpha over 2. So it's the number such that alpha over 2 of the probability in a standard normal is to the left. Got it? Okay. Now, over here, what's this number? Well, we could have done 1 minus capital phi inverse of alpha over 2, but because of symmetry, we just put a minus sign in front of that one, okay, which is fine. Okay, so does everyone believe this probability statement and see where it came from? Okay, so now what do? It's not in the form of a confidence interval yet. Remember, we have to have mu, the unknown parameter, kind of isolated in the middle. Well, we just do a little rearranging, that's all. So we do a little rearranging, and then on the left we have x bar plus capital phi inverse of alpha over 2 times sigma over root n. And then on the right we have something similar, but with a minus sign. Okay, this is still a probability statement until we actually plug in the realizations. And so then our confidence interval is just simply x bar plus this quantity and x bar minus this quantity. Okay? So here, this is still a probability statement, so you can think of x bar as being a function of random variables. Here, you can think of plugging in the realizations for x bar there. Okay? So a couple things I need to point out. One is that everything in this confidence interval is either known, or we can look it up in a book, or we can calculate it from our random sample. Okay? So we assume that sigma is known. That's what case one was. We know the size of the sample. We look this up in a book, and this we just calculate from our sample, from a random sample. So this is a number, and this is a number, and that's our 1 minus alpha confidence interval from mu. Okay? Make sense? Okay, so how about case 2? Yep.
Before we move on, so once we have that interval, what does it tell us again? Say alpha was 0.05, so then 95%. So then you say, and then let's say the interval was 1 to 3. So you would say, we know that the mean is between 1 to 3
No.
with 95. No,
No.
you said
No. So that was the thing that I said. It's kind of a pedantic point, but it's not. It's no longer. We can no longer make a probability statement once we plug in the realizations, because there's an unknown parameter mu, but it's fixed. It's not a stochastic object.
Right.
Okay. So you can't. Nothing is stochastic once we plug in the realizations. We just have two numbers in an unknown quantity. So it doesn't make sense to talk about probabilities. So to be perfectly honest, that's how most people kind of think about a confidence interval, because that's sort of the probability statement is how we construct it. But then once we plug in the realizations, it's sort of not really correct to make probability statements.
What are the two numbers tell you that? Sorry if you already answered it.
So no, I haven't answered it. They just give you information about the distribution of x bar. How?
If the interval is wide, then you know it has a large variance. And if
Yep.
the interval is tight,
That's it. Yeah.
can you just take the variance instead of the quantity?
Sure. Absolutely. Yeah. So this is only. So it's important for you guys to see confidence intervals because they're everywhere and to know where they come from. But it's really, it's essentially the same information that you would be presenting more or less if you just reported a standard error. Okay, but it's in a different form. That's all. That's all. Okay?
In economics, we often care more about tests. So we use the standard error to report to test, which is going to come in a minute. So for example, very popular test can be rejected with X% confidence that this is zero. But in other fields, for example in medicine, in all of the medical journals, they care about what they report is confidence interval. So it's a little bit a matter of convention, and I think it's very important to know.
Okay.
It gives you a bit of a richer sense of, because after all you might not care about, in economics we have a focus on zero, but we might not always, we might care about any other number. For example, you might be wondering whether your effect is large or it's small. Suppose zero is inside the confidence interval. That's one useful piece of information. But to go back to the discussion that Sarah had earlier, it's not a very useful piece of information if a million is also in the confidence interval. And it becomes a more useful information if you can, for example, I haven't told you what the unit was, so what I'm saying is kind of senseless, but it would, if zero is a confidence interval, but 0.001 is outside, you know the effect or whatever. So the confidence interval and readily available rich information. So we avoid your reader to have to multiply by some magic number that is going to come in a minute to interpret.
Good. Okay. Questions before we go to case 2?